So we left off where we should think our mode should be 49 because that's the one that occurs the most, right? It's the only one that occurs twice. But remember our other definition? It's the location of the center of the highest bar on the histogram. So I'm going to go back to our histogram that we created in the beginning of these notes. And I went ahead and I'm going to redo it. I'm going to put our median. We talked about 74, so I'm eyeballing it. There's our median. And then we're going to put our mean, which was 72.6, so it's about right there. There's our mean. And if we're following that definition of our mode being the highest, pretty much the peak, the middle of our peak, it would have to be there, which is not 49, right? Now let's make sense of this. How we're graphing this data is we're doing it in bin sizes of 10. So that's very different than just plotting this data as just a single test 49, a single test 68, and so forth. They're in bins. Why this is more informative is because this is where the majority of the scores are lying, right? Is right here, not down here, all right? So it's really important that we understand the difference. I'm really interested in where does the majority of our data lie, right? How did the majority of my students do? Of course, these 49 students matter, but overall, are students getting it? Or overall, am I providing them with the material they need to do well in the exam? That is what that information gives me versus looking at, just two people got these 49s. So that is why our mode is 80 points is the mode. Hopefully that makes sense to you. It's where the majority of the data is lying. Also, visually, it's the highest peak. So knowing this, so we just learned mean, median, mode. We're going to use these three terms visually. So we talked about, and I lost my graph, so I'm just going to give them to us again. We talked about something looking symmetric, okay? Something looks skewed to the left, which means you have a tail on the end. And then something skewed to the right, you have a tail on the right. Well, what we just learned is our mode is our peak. Our peak. Now remember, because this scale right here is frequency. That's how often it's happening. So that's why that would be our mode, because it's happening the most. Okay, the other definition we talked about is median. And that cuts your data right in half, okay? So it cuts your histogram in the middle. So we have, here is the middle, right? When something's symmetric, well, what do you know? That means our median and our mode will be the same when it's symmetric. Whereas if I go over here, skewed to the left, I have to cut this data in half, saying half the data is below it, half the data is above it. I'm completely eyeballing this, but this looks pretty accurate. This would be my median here. Whereas on this one, it'd be somewhere around there. All right. So the last piece of information is we have to talk about the mean. Remember, the mean is the average. Well, think about if you were adding up all these values, your average is actually going to be the same as your mode and your median when it's symmetric. So that is the beauty of having symmetrical data. Doesn't always happen, but it does happen. So what I can get from that is then if I tell you you have symmetric, your histogram is symmetric, and your mean is 48 points, then you know your median and your mode are around 48 points. They might not be exactly 48, but they're going to be pretty darn close. Whereas this one For your skewed to the left, this tail down here, this guy, he's messing up my average. He's pulling my average down, actually. So that's why, totally eyeballing, this is where your mean would be, because this tail is bringing it down. And so that's why I have right here that your mean is less than your median. Where skewed to the right, your tail is over here, right? So it's bringing your averages up. So your total approximation mean is about right there. So that means, your mean is greater than your median. So let's put this information into play. Let's see. So I'm going to do our last example. Suppose you know that a sample of 6 children's heights has a mean of 55 inches and a median of 45 inches. Well, I know 55 inches is bigger than 45 inches, right? And my 55 is the median. Okay, this isn't the way I wrote it, but it's saying here, hopefully you're okay with this, this is the same thing as saying this. I just wrote it how it was given to me in the order, but hopefully you're okay with that. This is saying the same thing as this. So I'm saying my mean is less than my median. So remember, that means my average is something is pulling down my average. So I like thinking about it like that so I don't have to completely memorize things. But if I go up here, where's your mean less than your median? Yeah, it would be skewed left. And again, because the tail is pulling it down. Again, if you're visual, it would look like that, right? Because this stuff would make your mean be over here versus your median is up here. So because of this, we know the distribution would have to be skewed left. All right, see you next time.